Hi, I'm Miss Hall, and this is Lesson 23, Solving Systems of Nonlinear Equations. Previously, you solved systems of linear equations by graphing, substitution, and elimination. You can also use these methods to solve the system of nonlinear equations. In a system of nonlinear equations, at least one of the equations is nonlinear. For instance, the nonlinear system shown has a quadratic equation and a linear equation. There's a sample. Under linear equation plus quadratic equation, we're going to sketch the possible solutions. So remember that a quadratic equation makes a parabola. Imagine we have a parabola and a linear equation makes a line. So one possibility is that they never meet, that there are zero solutions. Let's do another parabola and another line, or they could have one solution. And finally, parabola and line, they could have two solutions. Now let's do combinations of quadratic equations. If we have a system of two quadratic equations, where one has a positive a value, means it's opening upward, another has a negative a value, it's opening downward. They could again have zero solutions, they could never meet. They could have one solution. Or they could have two solutions. Example 1, solving a nonlinear system by graphing. So solve the system by graphing. Equation 1 is a quadratic. I know I'm going to be graphing a parabola, and equation 2 is a linear equation. So it'll be a parabola and a line. Starting with this quadratic, what I do to graph it is I put it in my calculator under y equals, then I go to table. I'll share with you what the table looked like. You do not have to write this on your homework or on a test. The ordered pairs went from -2 to -2, 7, -1, 2, 0, -1, 1, -2, 2, -1, 3, 2, 4, 7. When I was going through the table, I looked for the vertex. Right, here's the vertex. It actually appears in the table. And then I just wanted to mirror points on either side of the vertex that fit in this graph. And this graph goes +10 to -10. So this is how I chose the points that I'm going to focus on. So -2, 3, -1, 2. I can speed up my graphing by remembering that the axis of symmetry, then I can plot points on either side of the axis of symmetry. Okay, so there's the first equation. I'm going to call this y1. I'll label it y1. Switch colors, and now I have a line. I'm going to graph that using slope-intercept form, starting with the y-intercept is -1. So go to -1, up. That's a point of intersection. And then I do the slope of -2 over 1. So I go rise -2, I go down 2 over 1, down 2 over 1, or up 2 over 1, up 2 over 1. And I'll sketch the second equation. I'll call this y2. I'll label my graph y2. And then the solution to this system is the point or points of intersection. These graphs have one point of intersection. It's right there. It is 0, -1. So the one solution is 0, -1. Example 2, solving a nonlinear system by substitution. Solve the system by substitution. So substitution, we're going to set one equation equal to a single variable. It's going to be easiest here to set the second equation. The linear equation, we're going to isolate y. How did I write it? I wrote it as negative x plus 4. And then what I'm going to substitute in to the top equation is anytime I see y, I'm going to replace it with this expression, negative x plus 4. So we have x squared plus x minus, here's my y, but negative x plus 4 equals negative 1. X squared plus x minus both terms, so it becomes plus x minus 4 equals negative 1. So now I have an equation that's a quadratic equation. To solve this quadratic, I'm going to make one side equal 0 and use the zero product property. I'm pretty sure it's factorable. So I have x squared plus 2x minus 3 equals 0. Okay, so I have the quadratic in standard form. I could choose to complete the square, put it in the quadratic formula, but because this quadratic is factorable, I'm going to factor it. See, two numbers that multiply to negative 3 and add to 2 are positive 3 and negative 1. Therefore, my x values are negative 3 and 1 because of the zero product property. Those are the x values that make the binomial factors 0. And we are not done solving. Because a system of equations, right, there's x's and y's, we need to get the x-y pairings. So what I mean by that is we know that the x values are negative 3 and 1. Now we need to find the y values at those x's. So I'm going to use this equation. Say, okay, so y is equal to negative x plus 4. Y is equal to negative x plus 4. Negative 3 is positive 3, plus 4 is 7, negative 1, plus 4 is 3. So my solution here, there are 2 points of intersection if I were to graph this. That is negative 3, 7, and 1, 3. Example 3, solving a nonlinear system by elimination. Solve the system by elimination. This is the first system we're seeing in this lesson where it's 2 quadratics. So using elimination, right, we add or subtract the equations to eliminate a variable. These equations are already organized such that if we add them, we're going to eliminate the y's because we have a negative y and a positive y. And then we have 3x squared minus 3x equals negative 2. To solve this quadratic, I'll first get it in standard form. 3x squared minus 3x plus 2 equals 0. This quadratic is not factorable. So instead I'm going to choose to use the quadratic formula to find the x values that make it true. Quadratic formula is going to be x equals negative b plus or minus square root b squared minus 4ac all over 2a. This is 3 plus or minus 9 minus 24 is going to be negative 15 over 6. And I'm going to stop here. This is a problem. There's not a real solution, right? The square root of negative 15 is I radical 15, which is an imaginary solution. If there's an imaginary solution, that means that these two graphs never meet. There is no real solution to this system of equations. There is not a real x value that makes these true. I'm going to opt to solve the system using substitution. You could have also used graphing. For substitution, since they're both set equal to y, I'll set these equal to each other. So negative x squared plus 4 equals negative 4x plus 8. Want to get all the terms to one side, and I want the x squared to be positive, so I'm going to move everything to the right side. 0 equals x squared minus 4x plus 4. This is factorable. And we get x minus 2 times x minus 2. It's the same binomial. So the x value here is 2. That will make that equation true. And once I know what x is, 2. There's only one solution. Now I got to find the y value. If x is 2, I'll use the second equation because it doesn't have a squared term. You could use the first equation. See, negative 2 times 2 negative 4 plus 8 equals, well, I didn't use the second equation. The second equation is negative 4 times 2 plus 8. That equals 0. Therefore, there is one solution, and it is 2, 0.